Somewhere billions of light years away, two black holes are locked in an orbit so precise that astronomers can tell you years in advance the exact week one of them will physically punch through the other's disk of superheated gas. Not an estimate, not a rough guess. A prediction so accurate it has now been correct again and again for over 3 decades. The system is called OJ-287, and its strange behavior was first noticed by accident, buried in photographic plates dating all the way back to the 1890s, making it one of the longest continuously observed light sources in the history of astronomy. For over a century, something in that patch of sky kept brightening dramatically, then fading, in a pattern that repeated roughly every 12 years. In 1988, astronomer Aimo Sillanpää and his colleagues proposed an explanation radical enough that it took decades to properly confirm. OJ-287 isn't a single black hole, it's two. At the center sits one of the most massive black holes ever estimated, roughly 18 billion times the mass of our Sun. Orbiting it is a second, smaller black hole, still supermassive in its own right at around 150 million solar masses, locked into a tilted, elongated orbit that carries it crashing directly through the larger black hole's enormous surrounding disk of gas. Not once, but twice during every single orbit. Each time that smaller black hole punches through the disk, it superheats the surrounding gas violently enough to produce a brilliant flare of light, bright enough to detect from Earth. And because the orbital mechanics of two massive objects circling each other follow precise, well-understood physics, Sillanpää's team realized they could actually calculate exactly when those impacts should happen next. They predicted an outburst for 1994. It arrived on schedule. They refined the model and predicted flares for 2007, 2015, 2019, and 2022. Each one arrived within the calculated window, in some cases matching the prediction almost to the exact week, a track record almost unheard of in an area of physics dealing with objects this extreme, this distant, and this violent. For decades, though, all of this remained indirect evidence. Brightness patterns matching a model, but never an actual direct image confirming two separate black holes were really there. That changed in October 2025. Using an International Radio Telescope array, astronomers finally captured something nobody had ever managed to see before. Direct evidence of two black holes circling each other, identified by the powerful jets of particles streaming from each one. When the team compared their new radio images against decades of theoretical orbital calculations, the two black holes were sitting precisely where the model said they should be. Lead researcher Maury Valtonen described it plainly. For the first time, they had managed to get an image of two black holes circling each other, resolving a mystery that had stood unconfirmed for nearly 40 years. Follow-up observations released around the same time revealed just how extreme the environment around these two objects actually is. The jet extending from the more massive black hole showed temperatures exceeding 10 trillion degrees, wrapped in intense magnetic fields, a ribbon-like structure of energy stretching out from one of the most violent gravitational environments known to exist. And this story has an ending already calculated. Based on current orbital models, astronomers estimate that in roughly 10,000 years, these two black holes will finally spiral together completely and merge into one, an event that would release a burst of gravitational waves far beyond anything detected by our instruments so far, though by the time it happens, whatever remains of Earth will be watching light from an event that occurred billions of years before that light ever left its source. What makes OJ-287 remarkable isn't just the physics, impressive as it is. It's the sheer confidence of it, a system so far away that its light took roughly 3.5 billion years to reach us, yet predictable enough that scientists have set calendar dates years in advance for violence that happened before our own solar system finished forming. What do you think? Is there something almost unsettling about being able to predict cosmic violence with that level of precision? Or does it make the universe feel a little less chaotic than we assume? Let me know in the comments. Subscribe, because next time we are covering HD 199733b, a planet where the wind blows sideways at thousands of miles an hour, carrying rain made of molten glass.